Welcome to our video on the Pythagorean Theorem. Over the next 3 weeks we will be evaluating this particular theorem and applying it in real-world situations. So as we are continuing through this journey of learning, we need to determine what it is that is guiding our learning. So these are our essential questions for this unit. How is the Pythagorean Theorem used to identify side lengths? When can the Pythagorean Theorem be used to solve real-life patterns? As we progress through this unit, there will be various of situations where we can answer these questions. So we're going to start by going off of the basic knowledge that we have previously had. This is an example of a right triangle, and we know that it is a right triangle because it contains a right angle. So the measure of a right angle is always 90 degrees. We've briefly touched on this. The little square inside the angle is a representation to help us as mathematicians recognize, oh, I know that is a right angle. So about 2,500 years ago, a Greek mathematician named Pythagoras discovered a very special relationship between the sides of right triangles. This is just access information giving you guys background knowledge, so it's not essential that you write this down, but it is a fun fact if you're ever playing a trivia. And so what he realized is that if you have a right triangle with its sides and you square the lengths of the two sides that make up the particular right angle, which is where our little box is, and if you add them together, that actually you come out with the same number as you would get if you squared the other side. So Pythagoras derived this particular theorem to help others figure out side lengths. So, just to double check, because oftentimes we know that some mathematicians are a little bit crazy and we want to make sure that they're correct, we're going to do the work as well to check. So 3 squared is the same thing as 3 times 3, which when we evaluate it is 9. And then 4 squared is 4 times 4 when evaluated is 16. 5 squared is 5 times 5, which is 25. So now we have a little bit more of a simple math problem that we're familiar with. 9 plus 16 equals 25. Thinking to ourselves, is that correct? Hopefully you said yes, it is true, and it turns out it's actually true for any right triangle. So here we have another example where we have a side, and then we have this very long side, which is going to be a vocabulary word that we are going to discover. The two sides next to the right angle, we can represent those and square them. So 6 squared plus 8 squared equals our long side 10 squared. So now we solve 36 squared plus 64 equals 100. This is given an example for us. As it turns out, that also is true. So these two sides that we have that come together to form this right angle are actually called legs. They have a name, so this is a vocabulary word that we want to familiarize ourselves with. Legs are the two sides that come together to form a right angle. Next, I was talking, I'm sorry, getting ahead of myself. So when we talk about these two legs, we normally label them as A and B. This is just a variable used to represent an unknown. As we are solving, we will find the lengths of these values and we will actually get to where we know and we can plug in numbers for these variables. So now, as I was talking, there is a side across from the right angle which is also the longest side, and this is a very, very important vocabulary word for us. So it is called the hypotenuse. The hypotenuse is the side across from the right angle. It is also the longest side. So when we represent this with a variable, we usually label it with C. Going back to the Greek mathematician who discovered this, the relationship that Pythagoras discovered is actually called the Pythagorean Theorem. So that's something that's really easy for us to remember. And it is when we have the right triangle, the legs A, B, and C, then we can represent it as a squared plus b squared equals c squared. So that's where I was talking about a, b, and c are just variables, and at this particular point in time when we don't know numbers, we don't have anything to plug in them. But as we discover our problems, we will get numbers to plug in. The best part about the Pythagorean theorem is that it is actually something that we would use a lot of times. So let's suppose we drive directly west for 48 miles, and then we turn south for 36 miles. As you can see, we do have what is going on if you were traveling a block, but what we want to know is how far are you from where you started. So that would be the shortest distance between point A and point B, and to find that we are going to use Pythagorean's theorem. So we can represent that length by c, which gives us the problem 48 squared plus 36 squared equals c squared, or some unknown. So it asks why, and it's one of those things when you want to think of this, can you actually see where would the right angle be? Hopefully you discovered that it was between the sides that are 36 length and 48, so that would prevent our right angle, and it would give us our right triangle. When we're thinking back to our vocabulary words, we want to know what side is the hypotenuse. Correct. Side C, I'm sorry, I thought it highlighted. Side C is the hypotenuse because it is the one across from the right angle. So now we just want to calculate it. So 48 squared is the same thing as 48 times 48, plus 36 squared is the same thing as 36 times 36. Those are super huge numbers. So to save us, at this point in time, we would like to use calculators. 48 squared is 2,304. 36 squared is 1,296. When we add these together, we will get the solution that 3,600 is equal to c squared. I want you to think about this for a moment. Are we finished with our problem based off of what we just learned from solving multi-step equations? No, we are not, because c is not by itself. So how could we get rid of that? Says c squared. How could we potentially get rid of that square? Well, of course, technical difficulties. So c squared means the same thing as some number times itself is equal to 36. So a couple of different ways that we could undo that is we could actually take the square root of both sides, which would cancel, so we would get c is equal to, because remember what we do to one side we must do to the other, the square root of 3,600. This is terrible, guys. Which we can use our calculator, and when we use our calculator it would come out to actually be 60. So c squared is 3,600, therefore c itself is 60. So you ended up a total of 60 miles away from where you started.